All right, so it is 3 p.m. Eastern Time. We're going to go ahead and kick things off. Welcome everyone to the February webinar for the GE Additive Education Program. Today's focus is going to be around encouraging student exploration. Thanks again for making time in your busy schedules to come to this. Hope we'll find it useful. Okay, so some of the topics we'll be talking about today. We're going to start by looking at real-world examples of additive manufacturing and how to explore those with your students. We'll talk about relating 3D printing to your classroom subject, go over finding and solving problems, talk about working through failure, and then towards the end, we will do an example of the Polar Cloud workflow just as a reminder and kind of an explanation. And then finally, we'll end with a question and answer session. Okay, so we're going to start things off with a video from GE Additive. This is just a great, I really like this video. It kind of shows all the different possibilities of 3D printing, or at least a couple of them.
As the sign painter painted, name after name, no two descriptions were ever the same. And inside the factory, what did she find? A brilliant invention, one of a kind. 3D printing magical parts to help the whole world. A magnificent find for one little girl. As she departed, her mind did sing the song of a factory that can make anything.
All right, so I apologize if the sound is not great on that, but we really like this video for a couple different reasons. The key one being it just shows the curiosity and kind of exploration that can be sparked through 3D printing and the various uses that are out there right now. The video shows a metal hip being printed, shows how they're exploring dental implants as well as the use in jet engines. So there's a lot of different uses for metal 3D printing and by extension plastic 3D printing that you're experiencing in your classroom. Okay, so let's talk about real world examples. Why are real world examples important for your students to experience? I think the key reason is going to be it allows the students to really see the big picture. It's very easy for a student to look at something that they're learning and maybe not necessarily see the real world impact. But with 3D printing, as it is something that is still very new, but is being explored, it's important to allow students to see that real world impact, what's going on outside of the classroom. And especially when they can see that, what they're doing is new and it's very, very cutting edge. Additionally, as 3D printing is something that is still being explored by a lot of different companies, we're seeing new ways that it can be used on a regular basis. And because of this, students can find examples that really relate to what their interests are. We have in local schools who have been introducing 3D printing, we've seen a great way to get students started is by allowing them to explore 3D printing on their own for a little bit and possibly find things that relate to their own interests. A great example is the wheel that we have on the right-hand side of this slide. That's a metal 3D printed wheel that was done by GE Additive with cooperation with a wheel company called HRE. And this is exciting for a couple different reasons. The big one being that, the power of 3D printing and, the beauty behind it is really on display with this wheel. But additionally, for those students who might be interested in cars or, many different subjects and fields of interest, 3D printing can fit into any of those. And so allowing a student to go out and explore and find something that resonates with what they enjoy and relates to 3D printing is going to allow them to bring that learning opportunity all the way back around to something that they're passionate about. So a couple good ways to go about finding exciting things with 3D printing. We do recommend GE Additive's home site if you would like to get started. That's a great example as far as, that's where I found this Anything Factory video, as well as some different examples of what they're doing today. This is a golf putter, and then we also have examples like that 3D printed wheel, prosthetics for dogs, and they will be talking as well about things like what they're doing in aerospace as far as jet engines, reducing weight, things like that. The GE Additive Instagram page is also a fun site where you can see, great pictures. We've got the wheel that we showed earlier, a 3D printed putter. This is one of the nozzles that is 3D printed that goes inside a jet engine. And then, some great examples of metal 3D printing, including this bust of Thomas Edison. So these are just some fun examples of, what's possible. GE Additive is showing, here's some of the fun things that we're printing with metal. And by showing your students that, you can kind of build that interest. Finally, a great way for in the classroom, encouraging student curiosity and having them explore different, things that are available through 3D printing. We recommend keeping a couple fun examples on hand. And this is going to be helpful for a couple different reasons. For starters, you as a teacher get to explore 3D printing and find something that you might enjoy. But additionally, when a student can hold something in their hand that's been printed, feel the layers of what it is and maybe play with it, we really see that connection be made of, wow, this is something that is, exciting, and I'm holding it in my hands. And then when a student is told, now it's your turn to design something like that, or, your turn to 3D print something, that can be really powerful. We also find it, helpful for teachers because by exploring a Thingiverse or My Mini Factory, or even just Polar Clouds, shared objects, public objects, you can find exciting things to 3D print that, will also have your students encouraged and, wanting to explore more. Okay, so let's talk a little bit about integrating 3D printing into your subject. So the GE Additive Education Program took applications from lots of different teachers, and by extension, teachers of many different subjects. But as we've seen with 3D printing, because of the potential behind creating an object that, is only limited by your design, we're finding that it's able to be, used in many different subjects. And there's a couple ways that we can go about doing this. For starters, you can take an existing project that you utilize and find a way to work 3D printing into it. We know some teachers can, if you're working on a larger project and there's a couple different medians that students can, submit a final project in, adding 3D printing as an option to that medium will encourage some students to explore that, and by extension, allow other students to see and be like, oh, that's a way that, this student wanted to explore 3D printing that I hadn't thought of previously. We find that that's a good example. Science and math teachers might find it easier to incorporate 3D printing into their classroom, but there are other ways you can add it into, a couple different subjects. In incorporating it into other subjects, some fun examples that we find are just visual aids. Starting off with math, we've got a couple different, difficult geometries here that can actually be 3D printed and then explored hands-on by a student, allowing them to, it can help when they're exploring something and, seeing it for the first time. So I'll go ahead and pull up one of these the Mobius strip here. So this is a fun example of a 3D printed Mobius strip that if you were to, hold in your hand, can kind of be helpful in making that connection. I'm going to go ahead and click on Make to see a couple different examples here. So this is what if this is something that you were to talk about your students with and say, hey, this is, a kind of impossible geometry where this is all one surface. It's fun to be able to actually hold that in their hands. A similar example is going to be these Klein bottles, including, an interior shot. For those of you that are familiar, because of the way this Klein bottle is actually, because of the way the bottle is actually designed, technically it only has one surface. The entire surface is the same surface. If you were to travel around through the inside, you would, return to the outside, things like that. So being able to show your students this while going over geography can be fun because, it allows them to be like, oh, okay, I can picture this now rather than just a 2D example. Finally, here's a fun one that we found. Another fun visual aid is this Pythagorean theorem example where you actually start with the two different squares and then those pieces fold and show that the area of the two right angle sides become the same area as the hypotenuse. So these are just some fun math visual aids that you can 3D print if you're not ready to have your students designing and things like that, but can still incorporate in as learning aids. Okay. We have seen some history teachers that have 3D printers, and we've got some great examples for how you can incorporate history into 3D printing. There's been, a drive recently amongst institutions to scan, 3D objects and things like that. And so a couple different museums have done that. The Smithsonian, the U.S. Smithsonian actually has its own collection, and it's available at the site 3d.si.edu. And there's a couple different interesting models here that have been scanned and are available for you to explore. Now, it is worth noting that all of these scans are very, very high detail, more detail than necessary to 3D print. And as extension, some of these files are very large. But if you were curious about, just looking through some of the models and seeing if there's anything that you guys are studying, things like that, that would be a good place to start. Similarly, on My Mini Factory, there is a project that's called Scan the World that has been scanning, different art pieces and museum pieces from around the world that can be fun. So on this first page here, we've got quite a few different, sculpture busts and things like that. And so all of these can be downloaded and 3D printed. And so if you're, working through a specific span of history where you want to be able to see sculptures and things like that, this is a great way to do so. I will say with Scan the World, some of the art that can be found on here is not school appropriate. And I would recommend that if you want to explore these objects, not necessarily doing so with your students, but doing so on your own. Okay. As far as science goes, some fun visual aids are going to be plant cells, and I've got some great examples from Thingiverse that could be fun to print. And this would make for a pretty nice project as far as saying, okay, we're going over the plant, we're going to have different students design different parts of the plant, and we've actually already seen a GE program member of this year go through the process of designing and 3D printing a plant. So if you were to say to a couple groups of students, split students off into groups and then have one student from each group say, okay, you're going to be designing and printing the nucleus, you're going to be designing and printing a riboflavin, things like that. It'll allow those students to then each do their own part in incorporating and then creating a larger design. I've got another fun plant cell example right here. again, just a very nice way for a student to, take a look at something that they might have only ever seen in 2D, but explore it in 3D and, really get an idea of what that cell looks like on a different visual scale. All right. Finally, if you're an engineering teacher, this is a great way to incorporate STEAM tracks into your classroom. If you don't want to go about, taking an existing project that you're working on and altering it to add 3D printing, as a program member, you have access to all of the different STEAM Tracks modules that we have available, and I recommend you explore them and see if there's something that can relate to what your students are doing in the classroom. On the right-hand side, we've got the Tinkering with Turbines module, where a student is, as you can see, he's going to be connecting his small, wind turbine to I believe what's going to be like a voltmeter. And then by placing that turbine in front of a fan, he can see how much power is being created by the blade that he designed. So the stand and the motor holder at the top are all already designed. The student simply gets to design the propellers and the blades, and by designing that, they're able to test and see, how much energy can I create. We also, of another fun example is the rubber band racer that I'll open here. And so this is a module that, all of you as program members are going to have access to. To find any of these modules, I'll start from the home page here. When I click Explore and then Activities and Projects, this is going to bring up anything that I have access to. And then if I use this little publisher filter right here and click on STEAM Tracks, that's going to pull just our STEAM Tracks modules to the front. So here we can see Tinkering with Turbines, where we had a picture of, and then Building a Better Rubber Band Racer is another fun one that we recommend. Each of these modules is going to talk about the grade that it's recommended for, the subjects that it relates to, and then a little bit about, what the students are going to be doing in the module. And if I were to click on one of these, I'll actually then see the different teacher materials that are available, as well as the student materials that are available in red. All right. So in working through an engineering problem, the core of that is going to be, we've got this problem, here's what it is, and we need to work through solving it. If you're looking for other ways for students to explore, problem solving and really see that impact of 3D printing, a great example is going to be a design problem bank. Some of you guys might be familiar with this, and if so, you probably know a little bit more about it, but this is a school in Massachusetts called Brookwood that has taken on the idea of a problem bank where different teachers and students can submit a problem and say, hey, here's something that I would like to see fixed. I think it can be fixed with 3D printing. Do you have any good ways to do that? And then the 3D printing, engineering teacher, whose name is Rich, actually encourages his students to, take one of those problems and go through the process of solving it. I'm going to click on examples of solutions here, and you can kind of just see a couple different things here. One of my favorites is this little ball joint, this valve handle here, that was actually redesigned in Tinkercad and then 3D printed to be used again. There's a couple reasons that we really like this, but the big one is being, students get to see that impact, that actual impact of 3D printing when they solve something. They learn about empathy. They're able to, they're able to see what it is that's going on with 3D printing and how to, it can impact the community. Additionally, problem solving is really important, and it's something that as a student, looks at a problem and works through the process of prototyping. 3D printing is especially powerful when you're prototyping. We find that, learning opportunities really happen when a student takes a design, works through it, and maybe it doesn't necessarily work that first time, but they're able to test it and then say, oh, okay, this didn't work. Let's understand why, and then let's go back and try it again. Finally, by creating a problem bank, or at least allowing, maybe other teachers or students to come to you with problems to be 3D printed, um, it incorporates the community, the entire school, and really allows more than just the students in your class to see the impact that 3D printing can have. And we find that that can be really helpful in, spreading the gospel and allowing students to then see, oh, okay, I can fix things with, with what I'm learning in school. So I highly recommend that you guys check out this problem bank site. It can be found at designproblembank.weebly.com, and we'll send out a reminder with this link as well as some of the others that we looked at during this webinar for you guys to explore after it's over. Okay. So finally, in that prototyping and testing phase, I want to talk about working through failure. So we'll start out with a good quote that is often attributed to Thomas Edison, the founder of GE, but I've not failed not once. I've discovered 10,000 ways that don't work. When working with 3D printing, especially because it is new and especially because it is, it does have a learning curve to it, it's important to, help your students in working through failure and almost embracing it. So a couple different ways that we've seen teachers do this and kind of, encourage students is one great example is hanging on to failed prints. So similar to this, I believe it's a duck that we see on the right-hand side, hanging on to something that didn't print properly, especially if there's a learning opportunity there, is a great way to say to students, that's okay that it didn't work out. Let's figure out why. And that's where that learning opportunity can begin, when we take a look at something that didn't work as it intended to, and learning from it. So we've seen some teachers who will take failed prints and they'll stack them up, or they'll keep them in one place, and they'll actually say, okay, here's our learning wall. This is where we have objects that, it didn't work, but what did we learn from that object, and how did we change our design to make it better? Additionally, in doing so, if you don't want to necessarily hang on to that extra filament and things like that, you can just encourage their students to revisit their old designs. If your students are working with Tinkercad and they've made something and they've moved on to something new, they're going to be learning more about Tinkercad each time they, open up a model and start moving it around and start altering it. So encouraging them to go back to that, that first object they designed and say, what could you do better here? Or what would you like to add to this? It's going to allow them to really visualize the learning that they've been doing, as well as, make changes and say, okay, I could have done this better. Let's think about why or how I want to do so. All right. So that was pretty quick, but we'll go ahead and talk about the Polar Cloud workflow example. I wanted to have this on here because I know a lot of you are still, learning about the Polar Cloud and how to interact with it with your students, and I think that it's not necessarily something that's well documented. So I'm going to go over that now. So I'm going to start with an example by designing something in Tinkercad, and I'm going to go through the process from two different viewpoints. So give me 1 second as I boot this up. Okay. All right. So I've been exploring a couple different Tinkercad lessons recently, and I won't bore you with the process of going through it and creating the design, but I will pull open something that I actually created with the help of an Autodesk Design Academy course, which is free for educators. And so this is something that I created recently through the help of I think it's a 30-minute, maybe 60-minute course that talks about designing, this little pobble in Tinkercad and then going through the process of actually printing it. But so as you guys might be familiar, when an object has been completed in Tinkercad, there's a couple different ways that it can get to the Polar Cloud. But the easiest way is going to be using this export button right here, clicking 3D print, and then clicking on Polar Cloud. Now I'm going to go through this process initially as if I were a student and I wanted to 3D print something, and I have only joined my school, for example. So if you guys have, if you have your teacher join codes and your student join codes, and a student has designed something in or has joined their school using their student join code, this is the process that he or she would go through to design or to get something printed. So I'll click on Polar Cloud when I'm ready. Okay, we'll go ahead and click on Continue to Polar 3D. And what I'm going to land at here is the object page. Now, I've already logged into the Polar Cloud, but a student doing this for the first time would be greeted with the login page where they can then log in using Google, Microsoft Live, Office 365, or Facebook to log in. Now, upon landing here, if I am a student and I've used my student join code to join my school, I'm going to click on 3D print, and I'm going to use this center button here that says My School, and I'll click Send Job. We recommend that for students to be using this if you don't want the student necessarily to be experiencing the build plate, which I'll show you in a couple seconds. But when I click Send Job under My School, I'm going to get this little fill out your request page, and I'm going to use this drop down button here to select one of my one of my example schools. The Polar Garage will be my example school. And I'm going to leave a comment that says, please leave on my desk. All right, and then I designed this object in blue, so I'd like it in blue, and I'll go ahead and click Create. So if I'm a student and I've used my student join code, I'll see that school and I click on Print under My School. I can put any request in there if I wish, or those requests can be turned off. Those are things that we can toggle. And then as a student, my job here is done. I don't have to do anything else. I don't have to interact with a 3D printer. That's my step from finished design to getting it ready to print. Now, as the teacher, that job that I just sent is going to be, fulfilled or processed by the teacher themselves. So from the teacher's point of view, now that that object has been created, I'm going to go through the process of actually printing that. I'll start by clicking on Make, then go down to My Jobs. Since I'm the one who sent that object, I can actually see this here under My Job Requests. But if I click Manage Job Requests, I'm going to see anything else that has been requested by members of my school, which is the Polar Garage. Now, when I'm ready for these objects to be, to be printed, say for example, I want to print mine, my student Van, and then my student Greg's objects, there's a couple different ways I can do so. I can either click on one of these boxes on the left-hand side here and print them singular, one at a time, or I can click and grab a couple with the checkbox and then click the print button up here. I'm going to go ahead and do all three of these and click print. Let's see, multiple colors chosen. I'm going to go for blue. That's fine. Oh, you know what? It looks like we got a couple extras. Okay, so I think this job request had multiples in there. That's why there's a couple. Okay, so I went through and I deleted a couple of the extra objects here. And now I'm just going to go through the process of spacing these out so that I can fit them all on my build plate. So I'm selecting different objects by clicking on them on the build plate. I can also click on their name on the right-hand side here. Let's see. So I'm going to move this Raspberry Pi mount over to the corner. I moved it a little bit too far. Let's shift it back. All right. Move that piece right into the corner here. And then finally, this last one, I'm going to see if I can rotate it and still fit it in. If not, we'll scale it down. Okay. And okay, great. So it looks like if I kind of rotate my build plate here, everything's on the build platform, and we've got enough space surrounding each object that they'll all fit. can move this a little bit further in, and I think we're ready to go. So this was an example of taking multiple student print requests, object requests, and then actually placing them all on the build plate at once and getting ready for these to be printed. Again, this is done after a student, has joined their school using a student join code, has sent an object request, and then myself as a teacher is able to, manage those under make and then my jobs. As far as print settings go, I want to make sure that I have supports on. Okay, that's really important, especially for these, these curved objects. Some curved objects are able to be printed without supports, but I think it's going to be helpful for these here just because those curves are rather low. And then let's see. Oh, you know what? Here's a great example of something I would have missed. So this first object we have here, if I look at this directly from the side, this is actually going to be a really hard object to print because of those hooks and how they hang over. So those layers are going to begin to, the printer is going to begin those hanging layers, and it's going to struggle because there's no plastic beneath it in order to hold it up. Now I have one option here, which is to turn on supports to everywhere, and that would fill in this entire object with, additional plastic. But I have another option, which is I can actually take this object, I'm going to go back up to the top and click placement, and then click R and use rotate. And let's see, I'm going to do 90 degrees on the R axis, or on the X axis, excuse me. So now when I look at this object from the top down, I see that the 3D printer is actually just going to print that straight up. It's not going to have to work over, any overhangs and things like that. Okay. So when this is ready, let's see, when this is all ready, I've got my objects spread apart, I've got my orientations correct and things like that. If I want, I can change some of the print settings, but I think I'll be okay with default. At the top here, I can change what material that I'm using, depending on what's loaded in my printer. Let's see, I will do 20mm medium quality PLA. And I will go ahead and, let's see, I'll send this to one of our Dremels upstairs, and I will click print. Okay, so what we just saw, what we just went over there was the initial viewpoint was of a student who was 3D printing, or was creating an object and then sending it to their school's print queue. And then the second part was the teacher, actually taking that job request and a couple other job requests and adding them to a printer all at once. Now, currently, if the teacher who wants to 3D print that object needs to be added to the printer on the Polar Cloud, and also needs to be added as a teacher in the school itself. If you guys need any help with this, whether it's getting your join codes or actually getting set up with your school, please email me at geap@polar3d.com. I'll be happy to help you guys get your school set up. Now let's look at another example of how to go through the printing process from the student's view. So let's say I'm a student and I'm a member of a 3D printing club, or a maybe just a smaller class, and as a teacher you want me to have direct access to a 3D printer. The best way to do that is going to be through a group and then sharing a printer with the group itself. So I'll show you a little bit about that right now. I clicked on connect and then groups, and I've got quite a few different groups here. Let's see, what's a good example? I'll use this Shift Knobs group just as a quick example. So this is a group that's been designed and can be added by, say I want to make this for my 3D printing club students. I'll start off by creating the group, and then I'll actually go to settings. And at the end here, I want to have a join code enabled. By turning this join code on, I can give that to students who are a member of my 3D printing club or my smaller 3D printing class, and then the students can join this group. Now currently I'm the only member, but if you were to imagine having multiple students, you can then give them access to a printer. We have seen some teachers who, have a student who wants to take on an additional responsibility and is, really excited about the 3D printer. This is a great way to give access to those students, just a little bit more access to the 3D printer, and we can go over that now. So I've got one printer that's been shared with this group. It's currently offline, but if I wanted to add another printer, I click on my printers tab, I'll click share. Let's see, got quite a few offline here. Give me 1 second. Okay, so I'll use one of these Dremels here. I can share this Dremel to this group because I'm a member of that, or because I am an owner or manager of that Dremel, which if you are the teacher who's primarily using the 3D printer in your classroom, you are likely going to be that, especially if you're the person who added it to the Polar Cloud itself. So I'm going to add this top Dremel. Now, the students that join this group, I want to make sure that they have access to that printer and they can send jobs directly to it. I'll click on settings here, scroll down, and I'm going to turn on group members control printers. And then I will click save. So what I've just done is this is an on-off setting that allows all members of your group to see all queued jobs and to stop, start, pause jobs queued to printers shared with your group. So essentially now, when I give a student this join code and say, go ahead and join my special 3D printing club group, that student now has the ability to start your printer or stop your printer and queue jobs directly to it and actually get on the build platform. Again, I only recommend this for those of you who have, older students who want to take some ownership over the 3D printer and are kind of excited about it, or if you're in a smaller club, things like that. If you're working with a larger classroom of students and you need to print things quickly and you need to print multiples at a time, I recommend using the queuing process that I went over earlier. So now, if I were to go through this process of printing from, the viewpoint of what we just saw, let's go through that real quick. So I'm going to go back to my objects. I'm not going to start at Tinkercad since we've already covered, the sending an object from Tinkercad to the Polar Cloud. Let's see, what's a good object that we've got? I like this coffee scoop a lot. Okay. Oh, as a reminder, any of the community objects that you click on here, can be picked up and it can also be printed. So if you wanted this extra spool holder that hangs off the front of your Dremel and I wanted to click on that, I could print it. If I wanted to look up some of the snowflakes that were made for the last pattern challenge, I could do so. And this objects page will be changing soon. We're going to be updating it so there's categories and things like that, so it's a little bit easier to find what you're looking for. All right, so I'm going to go ahead, I'll go back and I'm going to grab my coffee scoop and I'll click 3D print here. And so last time I used the My School button, this time I'm actually going to use my printer and I'll click send job. And that's going to bring me directly to the build platform. Now, myself, I have quite a few 3D printers on this account. So on my drop down here, I have, abundant different options as far as what I want to print to. But if you're a student who's, working through this process for the first time, they should just have the one printer that they've been added to. I'll select the printer that I want to send this to. I can change any print settings that I would like, things like that. And then finally, I will click print in the top right-hand corner. Okay, upon clicking print, I again have created a job that's been queued into the line of the 3D printer. And so we'll see here, okay, we've got a couple makerspace tags that are being printed. My object gets added to the end of the queue, which is right here. And then I can wait for my turn for, the object to be printed. let's see, what's my notification? Okay, great. So earlier on, when you guys saw me go through the process of submitting a design through the My School button, there's a couple different things that I'm going to get as far as notifications, including, the job that I submitted. So I'm able to see that the job that I submitted has been queued. This is something a student would see when you go to print their object. And then actually when, the printer's been started with that object, I can see that my object was printed. And then finally, if I'm the teacher, I can see the file that was submitted to you, including, comments based around that object, which, when I get one of those notifications, I can know that I need to go to make my jobs and then manage and see the different things that need to be printed. So that's an overview of the two different ways that we look at as far as giving students access to 3D printing through the Polar Cloud. I know I went through those rather quickly. So if you guys have any, questions along that process, I'd be happy to answer those now. Additionally, we will be sending out a link with the recording of this webinar, and with that follow-up email, I'll include links to, the resources that I showed earlier, including the different models that were linked to, the GE website, things like that, just so that you guys can access those again. But yeah, if you guys are okay, we'll go ahead and go to question and answer session. I will say, if you guys have specific support questions, this might not be the greatest setting for me to answer support questions, whether it's technical, things like that. It's going to be best answered through email and then possibly a phone call. So if you guys do have, more specific questions, please feel free to email me. You can reach me at geaep@polar3d.com, and I'll be happy to, to get back with you and get you guys connected. If you guys don't have any questions and we're just on for the webinar, that is everything that we've got for now. I will say, keep an eye out. We're going to be launching a new challenge soon. The patterns challenge, we had a good amount of people submit to, but this next challenge is going to be a little bit more, focused on designing something that moves specifically. And so keep an eye out for that. We're going to be trying to cater it to a wide range of age groups. So, if the patterns challenge wasn't necessarily something that your students were able to work on last time, keep an eye out for this next one coming up. But yeah, thanks. And I am going to give a little bit of time for, questions to kind of gather up, and then I'll go ahead and start answering them. Okay. Okay, so Alexander, I'd like to answer your question. Alexander had the question, I have two printers that I believe are connected, but I see only one place for a student to send to. Is that going to be my print queue as the teacher? And then I choose where to send it from there. Yes, you are correct. So if I can give you a quick example, give me 1 second to get my windows out of the way. Here we go. So I will say make, and then I'll do my jobs, and then I'll click manage. And at this time, so I can choose, this is where all students will send to a specific school. So any of these, which is under the group title here. So here's the Pobble piece that I, sent over earlier. I'll click on this and then I'll click print. And it's at this time where you would determine which printer that object is actually going to go to using the drop down on the top right here. So Alexander, as you have two different printers, you'll be able to see, pick an object and then actually upon going here, see which printer you want to send it to. We have some information available right now as far as, you can see which printer has you can see which printer actually has, objects in queue and things like that. This is an example of, I could see, okay, this printer's offline. This printer is printing, has 4 jobs in queue. So I might look for another printer that has less objects in queue. Let me know if that makes sense. Nielka has a question from the Polar Cloud. How can we set up a group join code to share objects with specific students? Nielka, this is a great question. So I'll go ahead and go over that now. If I click on connect in the top left here, and then I click on groups, I'm going to go ahead and I will click create. I'm going to go through this process real quick, and I will say, let's make this Dean's 3D Printing Club. I'm not going to fill out the rest of the information just to keep this quick, but I'll go ahead and I will click. Oh, I do want to add an organization. I'm going to drop down and add this to, let's see, one of my schools. And you can add your school under organization here, and then I will click create. Okay, so I've got my new 3D printing club here. I'll go ahead and open it up. So the first thing I want to do is I want to make sure my join code is on, and I want to be able to share that with students. From my group page, I'll click on settings. I'm going to scroll to the bottom, and on the right hand side here, okay, I can see that join code is already turned on, and then I've got my little join code right here, my eight letter code that I can give to my students. Now, I want to share objects with my students, or I want to share, want my students to share objects with me. I'll click on this objects tab right here, and then at the top right, I can click share, and I'll see anything that I've uploaded recently to the cloud, and I can go ahead and add it to the group at that point. So let's say, okay, here's the snowflake that I just made for the snowflake challenge. I'll click share, and boom. Now any of my students can go in here, they can see this object, they can download it if they want, and they can bring it into Tinkercad, different things like that. Another great way to do this is if you go explore objects and you want to share with just a specific student, I'll click on my new Pobble here. I can click share, and I can do share with a specific member, and I can share it with someone via their email address or their name, or I can also click share from groups here, and I can send it to one of the groups that we just looked at. So either of those are options for sharing, but the first step is going to be creating that group for specific students. All right, so Alexander had another question. My elementary students struggle objects with scaling. Any video or other teaching tools that you can share? Let's see. When Alexander, if you don't mind, in terms of scaling, are you talking about making the size of the object? Size, great, thank you so much. Okay, so a couple ways to do this. I will say when working on Tinkercad itself, I believe most of okay, they're usually too small. Got it. Oh, that's a great question. Okay. I don't have a specific video off the top of my head that would be helpful. I will say that when your students are sending you their jobs, as far as, picking and choosing them and sizing them correctly, that can be done on the build plate. So if they're printing, through this process where you take the object and then actually scale it up, that can be helpful. As far as teaching tools, you might. I think there's a couple ways that you can go about doing this. I know you said you have some examples that you have printed. That might be helpful, especially examples that are labeled according to, the size that the object actually is. Maybe like a box that is a specific size, and then say, oh, this is a 30 millimeter by 30 millimeter cube. So when a student has designed something that's within that restraint, or, when you have a student designing in Tinkercad or another tool, and you can say, how tall is your object? And they say 30 millimeters. You have a 30 millimeter cube that you can say, okay, so that's how big this is going to be. I think that's one example. If they're making things that are too small and have too much detail on it for the printer to fulfill, it might not be a bad idea to print one or two of those objects that are too small, and then say, this is what that looks like as far as when it's too small. This is what the printer actually designs. We actually have a recommendation from okay, great. We actually have a recommendation from Nick, who says, I would suggest if you're in America, have them change the grid to inches. It's helped my students greatly because they're used to the sizing in inches. And then Alexander also said, teachable moment. Maker's Empire shows sizes. Does Tinkercad have numbers settings that show outer measurements? I believe Tinkercad does, and you can actually edit it as well. So let's see. If I'm on my grid here, let's see. Forgive me, it's been a minute since I've used this. So one example would be utilizing the ruler itself. Let's see. I think if I drop that here, does that work? That's not quite what we're looking for. So Nick recommended editing the grid and actually changing it to inches. If you're working with inches, that would be one way to do so. I believe this ruler here could be used to determine the size. Unfortunately, okay, I don't know what it is, but okay, maybe this is it. Where if we turn our ruler on, we will actually see how big it is. I know that on Tinkercad, though, if you select something like this, it is going to show you, your exterior sizes. And if you're, working with a different object, you can edit it as such. So it looks like when I've turned this ruler on, all of my exterior measurements are shown as soon as I click on my object. So that might be a good a good way to have students go about doing that, is click on the ruler, drop it on their work plane, and then actually, have all their sizes pop up as soon as they work on an object. Nick, thank you for helping with that answer. Sure, Alexander. So if I click on Edit Grid down in the bottom right-hand corner here, on Grid Properties and Units, this is where I can switch between millimeters, inches, and bricks, which I'm not familiar with bricks. But one thing to note is if you do, update your grid to inches and your students are working with inches, when you're exporting this to the Polar Cloud, you will need to scale it accordingly, because sometimes I believe most STL files work in millimeters. Let's test this out real quick, actually. So I've changed this object to inches. I'm going to click Export, 3D Print, Polar Cloud. Print, my printer. Okay, looks okay to me. Not bad. All right. We're approaching our hour end time. If you guys have any last questions, feel free to go ahead and put them in now. I'll hang around for a couple more minutes. If not, if you have other questions, again, please contact me. My name's Dean. I can be reached at geap@polar3d.com. I'd be happy to answer your questions. If you guys are struggling with other things and want to set up a time for a phone call or something like that we can work through specifics, I'd be happy to help you out there. So don't hesitate to reach out. But if there's no more questions, thanks so much for taking time out of your day again to explore this webinar. And yeah, we'll be looking forward to hearing from you all again soon. Thanks. All right, we don't have any more questions flowing in. I'm going to go ahead and end the webinar. Thanks again, guys, for coming, and you'll receive an email with a recording of the webinar, as well as some of the links that I used in my presentation, so you guys can go back and reference those. Thanks again.